To answer 1 and 2, we're just going to have to go over all of the characteristics, because the thing is, you don't know what graph's going to be there, you don't know what equation's going to be there. So talking about 1 and 2 at the same time, if we're talking about linear, linear is going to be in the form, whoop, pen's messing up, of course. Linear is going to be in the form mx plus b, or as I like to say it, nothing fancy. Nothing fancy going on in that equation. And of course, if you're looking at a graph, you're just looking at a line. That's going to be linear. The next one would be quadratic. In quadratic, when it comes to the equation, you're looking for an x squared. Okay, nothing higher than an x squared. As far as the graph goes, we all know that's a parabola. So either an up u or a down u. Next on the list is cubic. If it's cubic, you're looking for an x cubed. No power higher than an x cubed. This, if you remember, is like the little S-shaped graph going either up or down. That's your cubic. Next on the list would be a polynomial. A polynomial would be x's with any higher powers. So we've taken care of 2, we've taken care of 3. You see anything higher, it's a polynomial. If you remember the graph, that's going to be your kind of curvy, wavy, roller coaster rides, not necessarily sine and cosine graph, which is what that looks like. It could be fluctuating. All right. After that, we've got rational. Rational must have an x in the denominator. And the graphs, if you remember, are going to have 2 separate curves that don't touch each other. All right, it'll probably have some asymptotes if you can identify the asymptotes. But remember, you're looking for 2 curves that don't touch. That's going to be a rational. Okay? Exponential. An exponential is going to be some number raised to the x power. So the x is going to be actually in the exponent. And these graphs, the exponential graphs, are the ones that start off flat and then curve up. Or start off flat and then curve down. So this is the one that was actually on the practice midterm. That one was exponential because it started off flat and then curved up. The opposite of that is going to be the logarithmic. Come on. Pen doesn't want to write. Okay? Here's the thing. When you're coming to the equation, you see the word log, it's logarithmic. As far as the graph goes, it starts going up or down and then goes flat. Or starts going up and then goes flat. So it does the opposite of an exponential. Ran out of room here, so I'm just going to talk about piecewise on this slide. If it's piecewise, the equation is going to have this little bracket looking thing. And then it's going to have an equation like 3x plus 4, and then it's going to have like when x is greater than 2, or it'll say like x squared when x is less than or equal to 2. So clearly, obviously, to identify, the graph would be like, hey, there's a part of a line there, and then there's part of a curve here. It would be 2 separate pieces, which is why it's called a piecewise graph. All right, so that takes care of 1 and 2. Let's talk about number 3. Number 3 is a transformation. Y equals -4 plus 2 times x minus 3 squared. Now remember, you need to understand the concept, not just the problem, because on the actual midterm, the problem will be different. First thing we identify is open, down, stretch, and shrink. Open, down, stretch, and shrink is all determined by the number getting multiplied to the function. So we can see this 2 is getting multiplied to the parentheses. So it's getting multiplied to the function. The fact that it is positive tells me that this is going to open up. If it was negative, there was a minus sign right there, it would open down. The fact that it is a 2 tells me that it stretches. If it was a fraction, it would shrink. Okay? So that takes care of opens and stretch and shrink. The number that is on the inside being added or subtracted tells me left and right. And I do the opposite of what it tells me. So the fact that this is negative means I'm going to the right 3. So the number inside of the parentheses tells me to go left or right, and you do the opposite of what it says. Okay? The number being added or subtracted on the outside of the problem. Now, a lot of people like to say at the front of the problem. Doesn't necessarily have to be at the front. That -4 could be over here. It's just adding or subtracting that is not inside parentheses. That tells me up or down, and I do exactly what it says. So the fact that this is a -4 means I'm going down 4. Okay? All right. Number 4. Now, number 4 is pretty straightforward and simple. You just have to look at it. So I'm just going to draw a quick version of the graph right here. And it does something like that. Zeros on a graph is where it crosses the x-axis. Now, I know the one on the midterm is not, it doesn't look like it's exactly on some of these numbers, but just assume it is. You'll notice on the midterm, you need to look at yours, that this is at -2, this one's at 1, and this one is at 4. So the answers are -2, 1, and 4. Simple enough. Number 5, I worked this one a lot in class, so if you don't get it now, you're not going to get it. I need to find the zeros of an equation. To find the zeros of equation, you factor the problem. I first look for a GCF. I'm looking for anything that all three have in common. The numbers cannot be divided by anything, but everything has an x, which means I can pull an x out. If I pull an x from 2x cubed, it leaves 2x squared. If I pull an x from 5x squared, it just leaves a 5x. If I pull an x from -3x, it just leaves -3. Okay? I've got a perfect little quadratic here that I can now factor. At the top, I put whatever b is. At the bottom, I put whatever a times c is. Remember, these are in perfect order. A, b, and c. So that means my b is 5. My a and c is 2 times -3, which will give me a -6. I now look for two numbers that can multiply to get the -6, but at the same time add to get 5. Now, your first instinct is going to be 2 and 3. But I'm going to tell you right now, no matter how you change up 2 and 3 with positives or negatives, there's no way to get a +5 and a -6. So that's why you always have to remember to think about the number and 1. And in this case, it's going to be 6 and -1. 6 times -1 is -6. 6 minus 1 is a +5. Another thing you have to consider, is there a leading coefficient? Why, yes there is. And if there is a leading coefficient, you have to divide by that number. So I divide both of them by 2. That gives me an x, that's where this x was. This x just came to here. 6 divided by 2 becomes 3, so that's x plus 3. That can't divide, so I'm going to leave it x minus 1/2. Yes, for some of you who think, oh, I thought you put that in front and made it 2x minus 1. It's the same thing. Okay? But I'm going to leave it like this because it makes it a lot easier to see the next step, which is to set everything equal to 0. X equals 0, done. X plus 3 equals 0, I would subtract the 3 over, which makes x equals -3. X minus 1/2 equals 0, I would add the 1/2 over, and that gives me x equals 1/2. So my answers are 0, -3, and 1/2. Rule of thumb, if you pull an x out, there will always be an answer of 0. If you pull just a number out, no x, then nothing. It would just be what you had in the parentheses. Okay? Number 6. Once again, finding the zeros. But here's the great and wonderful thing about number 6. It is already factored, which means all I have to do is set everything equal to 0. Notice, this is just a number. Can I set it equal to 0? No, I cannot. Even if I did, does it equal anything? No, it does not. So x minus 4 equals 0, so that means x equals a +4. X plus 1 equals 0, which means x equals a -1. Yes, it is true, just like with the transformations. Anything inside parentheses, you want the opposite. All right? So there's that. Number 7, nice, quick, simple one. Number 7 is a subtraction problem. I have x squared minus 7x plus 6, and I'm going to subtract 2x plus x squared minus 3. Now when you are subtracting, you're going to take this minus sign and put it through that parenthesis. So this will be left alone, x squared minus 7x plus 6. But this parenthesis will become opposites, so minus 2x minus x squared plus 3. Now I just go through and combine like terms. I've got an x squared here. I have a minus x squared here, which means those two are going to cancel. X squared minus x squared. Negative 7x minus 2x is going to give me a negative 9x. And I cross them out just so I know I'm finished with them. And then 6 plus 3 is going to give me a 9. So the answer is negative 9x plus 9. All right, moving on. Number 8, a little bit of multiplying. X squared plus 2x minus 1 times 2x plus 1. All we're going to do here is a little distributing. Okay, you can either go little one into big one or big one into little one. It's not going to matter in the long run. So x squared times 2x would give me a 2x cubed. And then x squared times 1 would just give me an x squared. Now 2x times 2x will give me a 4x squared, and 2x times 1 stays 2x. Finally, negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. Now I just have to go through and combine my like terms. There's no other x cubed, so that's going to say 2x cubed. X squared plus 4x squared is going to give me a 5x squared, because that's 1x squared plus 4x squared. Those are gone. 2x minus 2x, well, those cancel out. And all I'm left with is the minus 1. So the answer to that problem is 2x cubed plus 5x squared minus 1. Oh, if you do this, okay. Number 9. X cubed plus 6x squared plus 9x all over x cubed minus 9x. In order to divide, you of course have to factor. So I look at the top. Is there a GCF that I can take out? No number, but there is an x. So I can take the x out. If I take an x from an x cubed, that leaves x squared. If I take an x from the 6x squared, that leaves 6x. If I take an x from the 9x, that leaves a 9. On the bottom, again, no number, but I can still take an x out. Take an x out, that leaves an x squared minus 9. Now I'm going to go ahead and tell you, you notice you have an x on both top and bottom all by themselves. Those will cancel. So I can now ignore those. On the top here, I've got myself another factoring problem. A, B, C. B goes at the top, which is 6. A times C would be 1 times 9, which would be 9. I'm looking for two numbers that multiply to get 9 and add to get 6. Those will have to be 3 and 3. There's no number in front of my x squared, so I don't have to worry about dividing anything. So I just leave it x plus 3, x plus 3. Now for my denominator. In the denominator, I pray that you notice that is a difference of squares. And whenever is a difference of squares, you can split it into what is being squared at the beginning. It's an x being squared. The 9 is a 3 being squared. And one of these gets a plus, the other gets a minus. That's just the rule of difference of squares. Now that I'm done factoring, I look to see anything they have in common. I notice that there's an x plus 3 on both top and bottom, which means I can cross those out, leaving me with x plus 3 over x minus 3. And that one is done. It's all factoring. Number 10. It gives me an f of x that equals x squared minus x minus 6. It gives me a g of x that equals 2x minus 4. It is asking me to find golf, g of x. G of x means that I'm going to take f and put it inside of g. So the way I do that is I write g, but instead of writing the x, I put a nice open parenthesis, because that is where f's going to go. So inside of g, I put f, which is x squared minus x minus 6. Now I just solved the problem. This one's a simple distribute. So 2 times x squared gives me 2x squared. 2 times negative x gives me a negative 2x. 2 times negative 6 gives me a negative 12. 2 does not get multiplied to the negative 4, because it was not in parentheses. So I just leave that minus 4. I've got some little like terms to combine here. So I've got 2x squared minus 2x minus 16. And that one is done. Now, keep in mind, if this had asked me for fog, I would have had to put 2x minus 4 for both of these x's. And for the one that has the square, I would have to split it into 2x minus 4, 2x minus 4, and FOIL it. So do keep that in mind. Because you never know, the one on the actual midterm could be one like that. All right, continuing on with number 11. Now we're into trig. So this one has a triangle. And it is asking me for the sine of b. Now remember, learn the concept, not the problem. I have to figure out what angle I'm referring to. In this case, it's b, because that will determine which side is the opposite and which side is the adjacent. Remember, opposite is always on the opposite side of the triangle. That's my opposite. Adjacent is right next to it. Hypotenuse is always the hypotenuse. Okay? Remember, treat this kind of like an arrow pointing to the hypotenuse. That's my hypotenuse. I look at SOHCAHTOA to determine that sine is found by doing opposite divided by hypotenuse. And so my opposite is a 15. My whoa, pen's messing up again. Clean that up. Hypotenuse is a 17, and so that is my answer. So that was number 11. Moving on. And for those of you who don't know, there is a class sitting in this room. That's why you just heard a whole bunch of papers flip over. Yeah. C, B, A. We got a 5. We got a 9. We got a 2 root 14. This one is asking for the secant of A. So once again, based off of the angle I'm at, which works because this is kind of the a different setup than number 11 was. Because now the bottom part is my opposite, because it's opposite of the angle that I'm trying to find. This is still the hypotenuse. Still got my arrow pointing to the hypotenuse. And this is my adjacent. Secant in terms of SOHCAHTOA is hypotenuse over adjacent. Because remember, secant is the flipped version of cosine. If cosine is adjacent over hypotenuse, you flip it for secant, hypotenuse over adjacent. The hypotenuse is 9, the adjacent is 5. So 9 over 5. Simple enough. 13 and 14 I'm going to do together because they both deal with this coordinate. Number 13 is asking you for cosecant. Now cosecant, we remember from trig identities especially, that that's 1 divided by sine. Sine is the y value. So that means it's 1 divided by negative 0.33. I just simply type that into a calculator, and 1 divided by negative 0.33 will give me negative 3.03. So that's the answer to 13. 14 is asking me for tangent of theta. Again, quotient identity, that's sine of theta divided by cosine of theta. Sine again is the y term, so that's negative 0.33. Cosine is the x term, so that's negative 0.94. I type that into a calculator, and I'm going to have to do that because I can't do that in my head. So 0.33 divided by 0.94, because the negatives are going to cancel out, and that gives me 0.35. So there's 14. You know what? 15 is too easy. I'm just going to put it right here. 15 is asking for sine of theta to be less than 0. To be less than 0 means you have to be negative. Well, on our cheat sheets, we've got this on us. A, S, T, C. A, S, T, C tells us where everything is positive. So I'm looking for where it's negative. So that means if it's positive, like for instance in quadrant 1, I can get rid of it. This S means sine is positive. I want it to be negative, so I get rid of it. That means tangent's positive, which means sine is negative. That means cosine's positive, which means sine is negative. So both of those work, which means I have answers in quadrants 3 and quadrant 4. There's 13, 14, and 15. Do keep in mind, you can't always pause and rewind this video. Cosecant of theta equals 6 over 5. We are looking for secant of theta. Now, if you need, you can draw a triangle. That is totally your call. Draw a triangle, label one of them theta. We know that cosecant is hypotenuse over opposite, because it's the flip version of sine. So that means this is 6, my opposite would be 5. And I can see here I need to find this third side, because secant is hypotenuse over adjacent. And my third side would be the adjacent. So that means I got to do a little Pythagorean theorem. So a squared plus b squared equals c squared. The only thing we have to remember is that c is the hypotenuse, so that's my 6 squared. It doesn't matter if a or b is the 5, we'll make it a. So 5 squared is 25, plus b squared equals 6 squared, which is 36. I subtract the 25 over, which will give me an 11. That's b squared, so that means I got to square root it, and b equals the square root of 11. So now I have my other side, square root of 11. That's my adjacent, so I can plug it into here. So my hypotenuse was 6, my adjacent was the square root of 11. Looks right, but it is not, because I cannot have a radical in the denominator. So how do we get rid of that? Well, we just simply multiply both top and bottom by that radical. On the top, that just gives me a 6 radical 11. I don't know where I got the 3 from. On the bottom, it just cancels the radical out, just leaving the 11. So 6 root 11 over 11. And that's number 16. Probably so far the problem that has required the most amount of work. Moving on to 17. 17 is a quick and easy one. It gives you an angle of 105 degrees, wants you to turn it into a radian. To turn a degree into a radian, we divide by 180. Just type that into your calculator, 105 divided by 180. If you get a decimal, make sure you know where that decimal to fraction button is. Hit that and it'll turn it into 7 over 12, but you got to remember to put a pi on it. So that's 7 pi over 12. I'm going to keep this up and do 18. Because 18 is just going the other way. 18 gives you a radian, negative pi over 9, and asks you to turn it into a degree. Now remember, you take the pi off of it. If I take the pi off of it and there's nothing up top, that means it's a 1. So I do negative 1 over 9, and this time I multiply by 180. So negative 1 over 9 times 180, punch that into your calculator, and you should get negative 20 degrees. Number 19. Number 19 says that theta equals 3, r equals 4.5, and it's asking you to find s. You got 2 ways to do this. One is with the formula, theta equals s over r. So 3 equals s over 4.5. That means I need to multiply these two together. So 3 times 4.5 in my calculator, which will give me 13.5. All right, continuing this on after we've been interrupted. So the triangle S over theta and R, we plug in what we know. I don't know S. I know that theta is 3. I know that R is 4.5. If your numbers are side by side, you multiply. If your numbers are stacked, you divide. So 3 times 4.5 still gives me, of course, the 13.5. All right? left my paper over here. Very similar problem, you just have to read through the words. Central angle, angle is theta, so that's 5. It says a central angle of 5 radians. Intercepts an arc, arc is represented by S, so that's 10. And it's asking how long is the radius, so that's my R. No matter which way you do it, whether it's with the theta equals S over R, whether it is with the pyramid, I'm going to save time and not work this problem all the way out, but notice here, you'd have the 10 on top, the 5 on bottom, so you would divide, so that means R is going to equal 2. All right, going to save a little time on that one. 21. There's not a lot I can really show you on this board when it comes to typing this in. You type that into the calculator. Remember, some of you with backwards calculators, you hit the 70 and then hit the sign. Other people, most people, you type it in directly the way you get. The one thing some of you do need to watch is it says round it to 4 decimal places, which means you have to pay attention to that 5th number. If that 5th number is 5 or higher, this gets bumped up. So this is going to become 0.9397. Got to watch for that because you know me, I will put it on the test both ways. All right, 22, very similar thing. You've got cosine of 130 degrees, 15 minutes. Now I can't stand here right now and talk to everybody about where you find these buttons on your calculator. Hopefully you remember. People with the short gray calculators, remember you type it in as 130, fraction button 15, fraction button 60, and then hit cosine. Everybody else, make sure you know where your buttons are. All right, you type that into the calculator, which I will try to do real quick. And you will get negative 0.64612, not bigger than 5, so I can just leave it. Oops, forgot about the negative, but the negative is still part of the answer. 0.6461. Okay? 23, once again, same thing, but what are you having to pay attention to in 23? The fact that it's a radian. Sine of 7 pi over 5. If you put your calculator in radian mode, you type it in exactly the way it looks. But if your calculator's still in degree mode, you need to type it in as 7 divided by 5 times 180. You're turning the radian into a degree. So no matter which way you do it, if you do it as a radian, make sure you put your calculator into radian mode. If your calculator's in degree mode, you can type it in like this, and it'll give you negative 0.95105. That's a 5, which means that's got to go up. 0.9511. 24. 24 is cotangent of 197. Now we learned and especially reiterated in trig identities that cotangent is the same thing as 1 divided by tangent. With that being said, that's exactly how I'm going to type it into the calculator. 1 divided by a tangent of 197. Those of you with short gray calculators, you're going to do tangent of 197, and then you have this button on your calculator that you push, which will do the 1 over. So 1 divided by a tangent 197, that gives me a 3.27085. 5 or bigger. So 3.2709. And that's my answer. 25. Gonna make it short and sweet. We are finding a reference angle. Whoops, meant to just put that in parentheses. First thing I gotta do is get it inside the circle. So I'm gonna add 360 to it because it's negative. And that's gonna give me tangent of 245. 245 is not in the first quadrant. It is in the third quadrant. So since it's in the third quadrant, I have to subtract 180. All of this is on your cheat sheet in the top right corner. So that'll give me a tangent of 65 degrees. Now I'm not necessarily done. I've got to check, should tangent be positive or negative if it was in quadrant 3. In quadrant 3, according to my ASTC, Quadrant 3, tangent is positive, so I leave it as it is. If tangent was negative, I just would put a negative right in front of that. Rule of thumb, if you type this into the calculator and it comes out negative, there should be a negative in front of your answer. Comes out positive, leave it alone. 26. We have sine of theta equals 0.5432. Notice it says 0 is less than theta less than 90, which means I'm just looking for my quadrant 1 answer. I'm finding theta, so that means I hit second sine, 0.5432. So second sine, 0.5432. And that gives me 32.9, which will round up to 33. So that one's 33 degrees. 27. 27 gives me a cotangent of theta equals 0.3425. Now the fact that it's cotangent, I don't have a cotangent button, so I'm going to type it into my calculator, second tan, and then I do 1 divided by 0.3425. So the fact that it's a reciprocal, I do 1 divided by the decimal before I hit equals. So second tan, 1 divided by 0.3425. Again, I only want the quadrant 1 answer because the directions just said between 0 and 90. And in that case, it's 71 degrees. Continuing this on, pretty much the same thing is going here. 28 gives me cosine of theta equals negative 0.1552. Second cosine, do not type in the negative. The negative is only there to tell me what 2 quadrants I'm in. And if cosine is negative, that means I am in quadrants 2 and 3. Excuse me, and I coughed directly into the mic. So that gave me 81 degrees. Again, second cosine, 0.1552 gives me 81 degrees, but I don't want that because I don't need quadrant 1. Quadrant 2 is found by doing 180 minus 81, which will give me 99 degrees. And quadrant 3 is going to be 81 plus 180, which will give me 261 degrees. So those are my answers. 29. Cosecant theta equals 1.52. Woo, pen's going crazy again. 0.5243. Remember, when I hit second sine, I've got to do 1 divided by 1.5243 because it's the reciprocal. All right, so second sine, 1 divided by 1.5243, and that gives me, if I round it, 41 degrees. I want that because it was positive. Quadrant 1 is positive. Sine's also positive in quadrant 2. My quadrant 2 answer is 180 minus the 41, which will give me 139. And so those are my answers. Continuing on number 30, exact same thing, except this time it's asking for it in minutes. So I got to make sure that I know where my DMS button is in my calculator. So I do the same thing. Second cosine, 0.2012. I want quadrant 1 because cosine is positive. I also want quadrant 4 because cosine is positive. Second cosine, 0.2012. Find that DMS button. Again, I do not have time to show everybody right now where their DMS button is. And it'll turn it into 78 degrees, 23 minutes, and 34 seconds. Let me go over this real quick. If the seconds are 30 or higher, your minute goes up. So that means this isn't 23, it's 24. Whoops, back to the pen. Quadrant 4 is going to be 360 minus that 78 degrees, 24 minutes. Now folks, if you remember, I taught you about your answer button. So you can do 360 minus answer. It's going to give it to you as a decimal. Once again, go to your DMS. And it gives you 281 degrees and 36 minutes. The seconds there were 25, so it does not go up. So there's 30. All right. on the long stretch, folks, you just need to know your graph. So I'm going to kind of take care of 31 and 32 at the same time. Remember, the sine graph, the sine graph is always going to pass right through the origin, all right, before it does all of its curves. The cosine graph is going to drop from atop the y-axis, all right, before it does its curves. The tangent graph is the one that is just the little snakes, but you got to remember, is it going up or down? That's really going to be your main concern. I want to make sure I'm doing it right because I'm worried I'm about to say it wrong. It's the one that goes up. All right, so it's the one that goes up. Cosecant is going to be your smiley faces and frowny faces. All right, smiley face, frowny face, smiley face, frowny face. Secant is also going to be smiley faces and frowny faces, but the difference here is, remember, smile exactly center. There's going to be smile there before it does the frowny faces and smiley faces. So keep these in mind. Secant won't have one sitting on the y-axis. I mean cosecant. Secant will. There's a smile exactly centered. And then finally, cotangent will just do the opposite thing that tangent did. So cotangent is going to be going down. I know these aren't pretty, but you just got to get the idea. So that took care of 31 and 32. All right? Folks, I can't really show you anything when it comes to 33, 34, 35, and 36. All right? Those are things you just need to know. You need to know your domains. You need to know your ranges. Okay? You need to know your periods. Remember, when it comes to amplitude, only sine and cosine have an amplitude of 1. No other graph has an amplitude. Okay? I can't show you anything. Those just are facts that you need to know. So let's go to 37, what we just got finished talking about, and that's trig identities. Cosecant minus 1. Cosecant squared minus 1. Look at your identities, folks, especially your Pythagorean identities. You've got one that says cotangent squared plus 1 equals cosecant squared. Now notice, if I subtract this 1 over, it would say cotangent squared equals cosecant squared minus 1. That's exactly what I want. So that means cosecant squared minus 1 is cotangent squared. That's also in your variations, so make sure you look back over your variations. 38 says secant squared minus tangent squared. Once again, I've got an identity that says 1 plus tangent squared equals secant squared. If I subtract that tangent squared over, come on, it would say 1 equals secant squared minus tangent squared. That's what this says, secant squared minus tangent squared, which means the answer is 1. Again, that is on your paper of variations, so look it over. And finally, I tried to make a 2 into a 3. Cosine times cotangent times sine. All I'm going to do here is turn cotangent into cosine over sine. This is multiplication, so that means I can cancel the sines out. Cannot cancel the cosines out because they're both on top. Cosine times cosine is cosine squared. That one is done. Number 40 asks, are you ready? I hope you are. Midterm is tomorrow. If you got any questions, post them in the comments with this video and I will try to get to them. Awesome, we're done. Now we talked, I'll cut off that part of the video.